Hey team, it's Dr. Bamper here, and I'm coming at you today with our next chapter video about taking measurements and some good practices. This is going to be really important for our next video talking about significant figures, showing why they're significant. And there's two ways that we can record our measurements. The first way is by using what's called an analog device or using a digital device. So when we take a look at our analog device, we're going to see that we want to go one place past our graduations on our tools, and our digital we use as is. So with digital, you guys are probably a little bit more familiar with this one. What I'm going to do for a measurement using a digital readout, I'm going to press the 0 button. On my balance, we're going to take a little trip over here. I've got my balance right here. We can see it's been zeroed out. I lift my lid up, place my item on the balance, and since this reads 13.18, there we go, 17, I would record this mass exactly as 13.17 grams. So that means when I write it down on my data sheet, I would record this exactly as 13.17 grams. There we go. So with digital, I use as is. Analog just means anything that's not digital. So if you have like an old school ruler, a stopwatch that's not digital, it's kind of like the old clock faces, a graduated cylinder, anything along those lines is going to be what we consider analog. So my goal is to go one place past the indicated measurement. So let's take a look at an example real quick. On here, I have an irregularly cut piece of paper. What we're going to do is we're going to use a ruler to go in and see if we can record a measurement real quick. So my goal is to measure this weirdly cut piece, what it is. So I line my ruler up, and you'll notice, I'm going to bring this a little bit closer. Sorry, big finger's in the way. There we go. You'll notice when I take a look at where that lines up, I have somewhere between my 0.5 and 0.6 mark on the ruler. I know it's a little hard to see, but what we're going to do then is we're going to estimate. Is it closer to the 0.5, closer to the 0.6, or closer to the 0.5? My eyes right here tell me it's a little bit closer to the 0.6 mark. So what that means is I would report this measurement then as 5.97 centimeters. And I got this 0.97 from a combination. Sorry, that was 9.57. There we go. Sorry, I get my numbers turned around sometimes. I have my 9.57 centimeters here. So I got the 0.57 from the fact that we're looking at 10 marks in between each centimeter. So when I blow this up a little bit, what I was seeing on my end, you get a janky drawing here. What I was seeing on my end was our ruler. We had our 9, our 10, and my paper ended right in between my 0.5 and my 0.6 marks. So I go from my 9, I work my way up. Here's the 0.5, but it's not quite to the 0.6. So what I'm going to do is I'm going to estimate in between. Maybe I'll say that's 9.57 centimeters, 9.58. You're going to see there's a little bit of fluctuation between the measurement you take and the measurement your lab partner takes. And that's okay. Just make sure you go one place past the indicated graduations. So this would be like 9.1, 3, to give you an idea that each one's a tenth. And I would write this as 9.57 or 9.58 centimeters. It's all going to be good. to serve the same purpose. So I always have to go one place past. And that even includes where I have different scales than I usually might. Part of your first laboratory assignment this week is going to be looking at some graduated cylinders and determining what the measurement is or how much each line is worth on this scale. So when I'm here, you'll notice I have 20 to 25, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines in between. So that means each line is worth half of a milliliter. So I'm estimating by the halves or by the whole, so I can probably guess confidently down to the 10th place. When I look at this measurement, I'm a little at the meniscus, so I got to get down eye level. I'm a little bit over the 17, 16, 17, 18 mark, but I'm under the 18.5 mark. So what I would do is I would say, well, so I'm a little bit closer to the 18.5 mark than I am to the 18 mark. So when I write down the measurement of what's in my smaller graduated cylinder, I would write that measurement out as 18, because we said it was the 18 mark, as 18.4 milliliters. So now I've brought in a taller cylinder. And in this taller cylinder, when I go to take my measurement, I'll see that my meniscus down at eye level here is perfectly even with the 60 mark. So when I go to write this measurement, I still have to report it as one place past because I'm very confident that it's right at that 0 line. So I have whole number increments on each graduation, which means I estimate to the tenths. So I would write my second measurement as 60.0 milliliters. This is going to be a really good habit to get into whenever you take your measurements, because you'll see in experiment 2, if you don't follow this rule, your data is going to be really, really bad. So as you're in the lab taking measurements, remember with digital, we go as is and we write our number down exactly the way it shows up on our readout. But when it comes to our analog, the rule is one place past our graduations. And our next video here is going to show why this is important in just a little bit.